Alright, welcome to a video on piecewise functions. These are a very interesting type of function. They behave very weird. So hey, first things over here, special type of function. They behave different based on the input, the x value. An example of what they look like is this. We have f of x equals 2 if x is greater than or equal to 4, and equals x if x is less than 1. So that looks a little weird, and it's going to look a little weird until we start graphing and going into it. And then just a note, if it's a greater than or equal to, less than or equal to, it's a closed dot. If it's a less than strictly or a greater than strictly, it's an open dot. And again, this may be a little weird for now, but it'll make a little bit of sense when we graph. So I'm going to graph 2 examples with you and then give you 2 examples to do on your own. So let's jump right into it. So we have f of x equals negative 2x minus 1 if x is less than or equal to 2, and f of x equals negative x plus 4 if x is greater than 2. So I'm going to graph both of these on the same graph. I'm going to graph them as different colors just so you can see where they are. You don't have to do this. Whenever you do it, you can just graph it with one solid color. I'm doing this so you can get a better visual. If it helps you, go for it. So what we're going to do is we're going to graph each of these individually. So we're going to take our negative 2x minus 1 if x is less than or equal to 2. It's in slope-intercept form, so our slope is negative 2 over 1, and our intercept is negative 1, our y-intercept. So we are going to graph that. So we go down the negative 1, down to right 1, and then I'm going to go down to right 1 again, and I'm going to stop here because this says x is less than or equal to 2. So I got to look at this dot that's on my x equals 2. Here's where this part of the graph stops. So my line's not going to go past that. So it's a closed dot because it's a greater than or equal to, or less than or equal to, I'm sorry. And we're going to draw our line, and when we draw our line, we're only going to draw it that way. We're only going to draw it that way. And we may need to make some changes to our line depending on our other part of our piecewise function. So let's look at the other part. So we have negative x plus 4 when x is greater than 2. So when x is greater than 2. So again, slope-intercept is negative 1 over 1. For our slope, our b is 4. So we're going to go up to 4. 1, 2, 3, 4. Put our blue dot. Then we're going to go down 1, right 1. So down 1, right 1, down 1, right 1. And on here, it's going to need to be an open dot because we're at 2 again, and 2 is where we're stopping. So it needs to be an open dot there. Except we're not going to stop for this. Because it says x is greater than 2, we can keep going because we only want things that are greater than 2. So I'll actually get rid of these right now. I'm going to go ahead and get rid of them. And then keep going with my slope. So down 1, right 1, down 1, right 1. So now I can draw this line. So this is our function. It looks a little weird because we have one line going to the left and it stops, and then we have another line picking up and going to the right. So one more example before I let you try some on your own. So I'm going to not use different colors here. I'm going to not use, actually, how about I will use different colors, and then when I do your examples, I won't use different colors. So let's go red, blue, purple. So we're going to graph each of these individually. So we have negative 4 if x is less than or equal to negative 2. So this is a y equals. So we go down to negative 4. It's right there. I need to change that to red. It's right there. And then it's going to be a horizontal line. But it says x is less than or equal to negative 2. So that means my line for this does not exist before this dotted line. So we got to get rid of this part here. So our line does not exist until we get to that negative 2. And then it goes. So now we're going to do the x minus 2. And that only exists when x is between negative 2 and 2. So our slope is 1 over 1. Our y-intercept is negative 2. So we're going to go down to negative 2. Put our dot. Then we're going to go up 1 over 1, up 1 over 1. And I'm going to stop right there because I messed up. I'm actually going to go to negative 2 now and go up 1 over 1 and then up 1 over 1. Now the constraints on our part of our function here have it between negative 2 and positive 2. So that means that this line is only going to exist between here. As you can see, these actually connect. So sometimes they are going to connect to each other. And we're going to do our last one. How about I separate these two? Now our last one says negative 2x plus 4 if x is greater than 2. Greater than or equal to 2. So our slope is negative 2 over 1. Our y-intercept is 4. And this is only going to work whenever we have x greater than 2. So we're going to go to our positive 4. Put a dot. We're going to go down 2, right 1. Down 2, right 1. You see we're right here. Now, we're going to do it again because this line only exists when x is greater than or equal to 2, which means that I can't use those purple dots there. So we go down 2, right 1 again, and one more for good measure. If this will work, there we go. And then we can draw our line from there. So altogether, that is our piecewise function. Now I'm going to have you try a couple examples on your own, so go ahead and do that now. And here's the solution to that, so go ahead and check your work with mine. Sorry for that little gap there. I didn't think this was playing. So, one more example and then we'll be done. So go ahead, pause the video and try this example on your own while I work on it as well. Okay, so here's the last example. Go ahead, check your work with mine. Make sure I didn't make a mistake or you. After that, you're done with this video.